Research is about the measurement of dye-jet azimuthal correlations in 200 GeV Deuteron-Gold collisions. And here's some background information. This plot is the forward pi0 correlation functions using Deuteron-Gold data over here compared with the proton-proton data over there. You can see the paired particle protection yield is suppressed for the Deuteron-Gold data. And this is the plot of the nuclear modification ratio as a function of momentum fractions. Those two plots are for gluon. We can see at the lower momentum region, there's actually less gluon per proton in the nuclear compared with a single proton. To explain those phenomena, there's something called color glass condensate. We all know a gluon can split into two gluons, and that will increase the gluon density. What the color glass condensate is when the gluon density is high, there's 2-to-1 process, and when two gluons merge into one gluon, that will saturate the gluon density. And for the heavy ion nuclear, since there are more gluon interactions, there's actually more 2-to-1 process and less suppress the single particle and the pair particle protection yield. The color glass condensate also predicts that the evasive width should increase for the heavy ion collisions compared with the proton-proton collision. And that's what we're trying to measure. Since we are mostly interested in the low X gluon from gold nuclear, so we're interested in the events when there's mid or high X quark meets low X gluon from gold nuclear, and according to the conservation of momentum, the products will fall into the central and forward rapidity range. Before the correlation, we did the Hall tower identification, where we identified and removed the tower in EM cals which has abnormally high or low number of events measured. And those are two plots for one sector before and after the Hall tower cut. And then we did the pi0 reconstruction. Since pi0 is going to decay into a pair of photons, we are reconstructing pi0 with the photons that we detect in the EM cal. We fit the mean and width of the pi0 mass peak with two different functions. And then for any pi0 from a specific sector at a specific PT, we can find the size of the mass window, and we can tell if the photon pairs pi0 it's in the mass window or not. And we use the 3 sigma cuts for the future analysis. And here's some results for the central pi0 charge hadron correlations. We choose the trigger particle pi0 from 2 to 3 GeV and associated particle charge hadron also from 2 to 3 GeV. And we fit the result with two Gaussian peaks, one at 0, one at pi, and we use a constant plus a sinusoidal function as the background. So for the future work, we should continue to analyze the flow rapidity. There are some more QA and correlations to do. And also we should look into the centrality dependence. Since we are using the 2016 Deuteron-Gold data and there is no proton-proton run in the same year, so we should look into compare the high centrality data with the low centrality data, which sort of describes the behavior of proton-proton collisions.